So, hello everyone, hope you're doing good and welcome back to my channel. Today we are at day second of the April Daily Leetcode Challenge and we have a medium level question in front of us. It's question 2300 successful pairs of spells and potions. Okay, so let me give you a gist of what the question is. We are given a spells array, at the same time, we are given a potions array, right? And we are given a number success integer. So what we have to return is for let us say 5. 5 is the zeroth index of spells array, right? 5 is zeroth index of spells array. We have to say how many portions like that exist in the portions array such that when multiplied with 5 gives a success greater than 7, greater than or equal to 7. So see here they have clearly mentioned a spell and a portion pair is considered successful if the product of their strengths is at least success. What that means is see what will be answer of 0? Answer of 0 will be the number of such portions which when multiplied with spells of 0 will give a success greater than 7. I will again repeat. For example, C5. Okay, let us consider example of 5. For 5, these are the various portions with which we can multiply 5, right? 5 into 1 is 5, 5 into 2 is 10. See, from here onwards, all the portions which were multiplied with 5 will give a success greater than 7, right? Success means the multiplication, right? 5 into 2 is 10, which is greater than 7. 5 into 3 is 15, which is greater than 7. 5 into 4 is 20, which is greater than 7. And 5 into 5 is 25, which is greater than 7. So there are four such numbers in the portions array, which when multiplied with the spells of 0 gives a success greater than 7. That's why here the number 4 comes, right? The answer, the first one is 4. Now coming to the spells of 1, okay? There is a second index, spells of 1. How many numbers like that exist? Okay, 1 into 1 is 2. Sorry, 1 into 1 is 1, 1 into 2 is 2. So, like that, see, 1 into 5 is 5. There is no number in that which, when multiplied with spells of 1, gives a success greater than 7. So, here 0 comes, right? Now, coming to index 2, which is the third number in this case. So, 3 into 1 is 3, 3 into 2 is 6, 3 into 3 is 9. From here onwards, whichever number multiplied with 3 gives a success greater than 7. So, the answer here is 3. So again, read this portion. A spell and a potion pair is considered successful if the product of their strengths is at least success. We have to return the number of such potions for each of the spells array. So answer of I will be the number of such potions for spells of I, for which their product, that is their success, is greater than the success given, greater than or equal to the success given. I hope the question is understandable. If you have not understood, just see, just to answer the case of 5, right? For 5, how many portions like that exist here, such that which when multiplied with 5 gives a success greater than 7. So like that, if you see here, these are the portions. Okay, sorry, these are these are the portions which when multiplied with 5 gives a success greater than 7. Okay, the product is called success, right? So here the number is 4. Okay, so similarly it's the case of others. So what we can do is see this question can be solved in many ways. There are two pointers approach, but the approach which I want to show you, see, because yesterday also we did a binary search approach, right? So today also I want to show you a binary search approach. Where binary search can you see this, currently this portion is sorted. This may not be the case. For example, see here, this array is not sorted. So definitely I will have to sort the portions array. And remember, once the multiplication starts getting bigger than the success, then the whatever numbers follows will always be greater than success. For example, 5 into 2 is 10. Okay, 5 into 5 was not, sorry, 5 into 1 is not greater than success. But 5 into 2 is greater than success. Once I have 5 into 2 greater than success, 5 into 3, 5 into 4, 5 into 5, all of these will definitely be greater than success. So I need to find that particular number, which is the first one in this sequence, which is multiplied with the specify, which will give the success greater than 7. That's what it is, right? So what we can do is we can use a binary search. See, n is the length of spells, m is the length of potions. Okay. What I'm doing is I'm creating answer array. See, answer array will be of the length of spells. Okay. So whatever is the length of the answer will be the same as the length of the spells. Okay. For each of these spells, okay, for I in range n, that means for each of the spells, sorry, what I'm doing is I am doing a binary search in the sorted portions array. I am doing a binary search in the sorted portions array, as I told. See, please remind my video and see this. I've created a lot of efforts. I've made a lot of efforts to create these videos. I may be saying it a bit faster way, but for you to understand, if you maybe you can make this video in plain slower way, right? In a speed of 0.5x or 0.75x. If you're not able to understand, please rewind and see these parts. You cannot skip this without understanding. You have to understand each and every line in the video. Only then you will be able to understand this solution, right? See, I will do a binary search here. For each of these values, I will do a binary search here till I find a value which gives a success greater than 7. Once I get that, I will be for all the numbers like succeeding that, definitely the success will be greater than the success given. Okay. So I'm doing a binary search here. This is the binary search, and the low will be 0, high will be last index in the portions array. This is a simple binary search, right? But what we are comparing here, we are comparing the multiplication. We are calculating mid, that portions we are multiplying with 12 of I. So 12 of I will remain common throughout this binary search. Okay. For each I, we will do a binary search. That's why 12 of I will remain common. If that case greater than, sorry, if that case less than success, then equal to mid 12, else L h equal to mid minus 1. Okay. This will continue. It will one see I am taking L here finally, okay? L is always the number which yields a success greater than that. Okay. Once and for example, see in case of five, it will be the number two. Okay. So what is the index? One. I am subtracting one from the number itself. What's the length of this? Length of this is five. Five minus one. L is in this case is one because five into two is 10, right? So what is the index of two? Index of two is one. So I'm doing five minus 1, which is 4. See, the answer is coming here. That's how. Okay. Now coming to the case of 3, because the case of 1 is anyway 0. So I'm going to the case of 3. 3 into 3 is 9. Okay. This is where it's starting to be greater. So this index will be L. So what is the index? 0, 1 and 2. So 5 minus 2. Okay. 5 minus 2. Here 5 minus 2 will come. Okay. Here 5 minus 2 we are doing. 5 minus 2 is 3. So that is the answer coming here. So always remember, whenever we are doing a binary search like this, okay, L will be always the number which is greater than the success array. Okay, greater than the this portion. See, success we are calculating, right? So it will always return the number either greater than or equal to success. Okay, and finally we are storing in the answer array. Answer array, as I told you, it will be always of the length of spells. And yeah, so see this. I am again sorting this part, right? This part you should not forget. I'll just show you how it's sorted. See, in this case, it was already sorted. If you see the second case, you can clearly identify it was 858. Now it became 588, right? In this, we will do the binary search now. Okay, so that's all about it. And see, coming to the time complexity, what I will say, see, this is of length m, right? Portion size is of length m. So doing a binary search on this will take log m, right? And we're doing this for n times. So n log m. This is how it will be. It's n. I will write O of n times log of m. We are doing a sort here as well. So this will be O of, see, it will be portion of m log m. So these are the time complexities, and obviously we are creating array, right? So this will, see, if you compare the space complexity of it, so it will be of the order O of n, right? So space complexity is of the order of O of n, and time complexity will be a combination of these two factors. Okay, it will be m plus n log m plus n. Sorry, if you add the time complexity of these two, see, log is common, so it will be of the order m and log m. Okay, so yeah, friends, this is all for today. If you have any else, please comment below. Thanks a lot.